Last episode, just-in-time retrieval kept dangling a question. When the model needs a fact it doesn't have, where does it look it up? Here's the answer, and it's the most important pattern in production AI. A plain model is a closed book exam taker. It answers from memory, and when memory is fuzzy, it confidently invents. RAG hands it the book. Think of two kinds of memory. Parametric memory is what's baked into the weights. Everything the model learned in training. It's frozen, it's lossy, and updating it means retraining. RAG adds a second kind, non-parametric memory, an external index corpus. You can swap it, grow it, correct it anytime. The model's brain plus a library it can read. The loop has a name: retrieve, augment, generate. Retrieve the relevant passages, augment the prompt by pasting them in, generate the answer grounded in them, and the payoff is concrete: less hallucination, real citations to the source, and fresh or private data without touching the weights. A small model with a good library beats a big model guessing. There are two phases and people conflate them. Ingest happens offline, once per corpus update. Load documents, chop them into chunks, embed each chunk into a vector, store the vectors in a database. Query happens online. Every request, embed the question, find the nearest chunks, paste them in, answer. The one rule you cannot break: ingest and query must use the same embedding model, or the geometry doesn't line up and search returns garbage. RAG isn't free. It adds retrieval latency and a whole new failure surface: bad chunks, bad embeddings, bad ranking. And even with perfect passages, the model still has to read them correctly, which is why later in the course we'll measure whether the answer is actually grounded in the source. And remember the ladder from stage 4. RAG is the right tool when the gap is missing facts. Wrong behavior or format is still SFT or PEFT. Let me draw the whole loop once: 2 lanes, ingest on top, query on the bottom, and show you the one component that bridges both. Top lane, ingest, offline. Documents flow into chunking, cut into passages, then each passage goes through the embedding model into a vector, and the vectors land in the vector database with their metadata. Run this once or whenever the corpus changes. Bottom lane, query online. A question comes in, goes through the same embedding model into a query vector, then nearest neighbor search pulls the top matching chunks out of the database. I'll glow the shared embedding model crossing both lanes. That's the rule. Same model, both sides. Now augment and generate. The retrieved passages get pasted into the prompt, system instructions, then the passages, then the question. And the LLM produces the answer grounded, with citations back to the chunks it used. That's the full open book exam. Retrieve, augment, generate. But the whole thing rests on two foundations I waved past: how you cut the documents into chunks, and how text becomes a vector where similar meanings land near each other. Get those wrong and retrieval can never recover. Next, chunking and embeddings, where meaning becomes distance. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.